found that we actually could deliver CO2 right into open air environment crops, and the crops will gobble up the CO2, and we get far higher yield increases, higher quality, more fruit production. With tomatoes, we actually did 120% increase in yield. I mean, it was phenomenal. Not only are we sequestering CO2 and creating a market for it, but it improves the water use efficiency of the crops by 80, 90, 100%. And that's what the sensors do for us. So they pick up the daily temperatures, the wind, the light, radiation, and all that feeds into an algorithm, and it says, okay, at any point in time, put a prescriptive level of CO2 out there, and the plants just thrive on it. So our system is designed to release the CO2 right where the light is incident to the plant, because it's the light and the gas that are interacting with each other. Right? They're uptaking the carbon, and the sunlight through photosynthesis converts it into carbohydrates and sugars. Our core values are have fun, be agile, be innovative.
Boom, what's up everyone? Welcome to Simulation. I'm your host, Alan Sakyan. We are still at the New West Summit, the world's leading cannabis tech conference, and we are now sitting down with Stewart Erickson. What's up?
Yeah, having a great show here. Really excited to be here on your TV program, and want to talk a little about CO2 and ag gas.
Yes. Thank you again for coming on. We greatly appreciate it. And ag gas, as Stewart said, is what he's building since 2013. So it's been 5 years, and founder and CEO. And also we have quite a bit to unpack about this, because this is not just about cannabis, although that is where it's been the last year or so of focus. Let's start off in 2013 talking about how you guys started optimizing agricultural crop yields for peppers and tomatoes, and I'll pass you the mic and then you can take over.
Well, sure. It all started as kind of a vision of creating a market for CO2, and we've been working with some of the world leading people on climate change, and everybody kind of concurs that in order to have a solution, there has to be a market for CO2, and that market is agriculture, and I'm the man that happened to have picked up on this. So we did a number of research trials involving UC Davis, Fresno State University, the USDA out in San Joaquin Valley, and found that we actually could deliver CO2 right into open air environment crops, and the crops will gobble up the CO2, and we get far higher yield increases, higher quality, more fruit production. And with tomatoes, we actually did 120% increase in yield. I mean, it was phenomenal. And the byproduct of this whole thing that really starts to get exciting for the state of California and other nations, not only are we sequestering CO2 and creating a market for it, but it improves the water use efficiency of the crops by 80, 90, 100%. So it really ultimately can be a big water conservation technology. So I want you
to tell us about the science there. So how is spraying the little bit of CO2 onto the tomato plant, how does that both increase the yield up to 120% more, and how does it sequester CO2, and then also how does it decrease the water use?
Sure. So with the tomato project, where all these universities and the USDA was involved, they went and they dug up the plants, and so while we had this 100% plus yield increase on the fruit, what they found is the plants absorb the carbon dioxide through the leaves, and they take that and they reallocate it into root structure and soil carbon. So it's building soil tilth, microbial activity, all the things that an organic farmer wants to see. And the CO2 is considered organic, right? It's not a chemical. It's the carbon building block that all plants need. And the other thing that's interesting then is the huge water loss. If you think of all of San Joaquin Valley, it's through the leaves of all the orchards and the vineyards and the crops out there. And the CO2 controls those little stomatal openings where the gas exchange occurs. So when we do a tiny bit of elevation of the CO2, there's a huge reduction of water loss through that plant. So it just impacts the plants physiologically in a really great method.
So it's the carbon, it's the CO2 that goes down, they absorb through the leaves down to the root structure that then makes it so that the plant needs less water to be able to thrive?
Not exactly. They have more access to nutrients and the water that is there. But the stomata openings, there's thousands of these little openings on the underside of the plant, of the leaves. And that's where the carbon goes in, 1 molecule in, 10,000 molecules of water out. And so when we give it a tiny bit more of the CO2, that stomatal opening closes, and now the water loss plummets out of the leaf of that plant. I kind of compare it to somebody when they're like climbing Mount Everest and they become anemic at high elevations, right? That's kind of what's going on with the plants almost every day, because the way they evolved was in a really high carbon dioxide environment, and now today there's only 400 parts per million. So the plants not only like the CO2, but they thrive on the CO2, and they allows them to use a lot less fresh water to go through the photosynthetic process.
Okay, so the idea is that we're talking as plants evolved over the last billion plus years, that we have had a time period of 800 parts per million of CO2 or something much greater, and then plants were thriving more, kind of having more CO2 to pull from, to grow with, and now having it back down to 300, now 400 ppm's just much. So you give them that little boost of CO2, and then that increases the yield. That's so interesting.
Yeah, so the company, is really what we were talking about earlier, is we're really mission driven. We realize though, well, let me go slow. Because we're mission driven, it's really allowed me to attract some top business talent, people in California and other areas of the country that went, Stu, we want to be involved with you. We want to be involved with this. And because of the environmental benefits. And we realized that we have to build a company, right? So we have to be profitable, and that's what's allowed me to build a great management team and attract financing. But what happened is once California passed Prop 64, we had a hard conversation. It's like, well, are we going to screw around with tomatoes and almonds over here in Central Valley? Or are we going to go have a conversation with the cannabis guys? Yeah. And we did that, and we held some roundtables, found out the people were super great, and the conversation was really 180 degrees, because the cannabis guys were doing this in their college dorm rooms 20 years ago, right? And they're like, you can do this outdoors or in a greenhouse or in a hoop house, and we go, yeah, here's all the university data on the peppers and the tomatoes, and they're like, we're in, right? Yeah. So we ran this since October last year. We picked a really reputable cannabis grower up in Ukiah, California, and we ran trials, very similar, held exactly equal, all the nitrogen fertilizers, the planting, the varietals, even the crew that managed the grow site, and especially the irrigation water, versus the same hoop houses with CO2 introduced with our carbogation service. And last fall, we got a validated report with the CPA firm out of Santa Rosa that pegged it at 27% yield on that fall harvest. And now a month ago, they did their second harvest this year. They got over 50% increase. And when you look at the price per pound, at $1,000 a pound and getting 30 more pounds per hoop house, the numbers get really staggering in a hurry. So we are now building these more high-tech systems. They have little low-voltage sensors. We can deploy the sensors out in the field. They're wireless, and the data really allows us to drive these systems. So what it does is it puts just a prescription amount of CO2 out there, just the right amount of CO2 in the right place at the right time. The cannabis growers can go through their normal function all year long. It's on a glider system, so they can install mesh trellis, do their harvesting, replant, reset the system, and go through another cycle. So if we get in their way, we're in trouble. And the system's all designed to do that. Plus, they get a grower user interface on their phone, so they're going to get data out of their grow rooms that they otherwise don't have. So it's eventually it's organic, and we think there'll be some logical migrations in the market. For us to either go right over the fence into the orchards or vineyards with the technology, or into other geographies. But right now, we're really focused on building the company and the management team and the capacity, the supply chain, all the things that go with building the company, so that this broader vision that all of us at the company hold can become a reality.
Oh man, this is so cool. So the tiny bit of added CO2 to cannabis, even outdoors, can increase, showing right now 50% increase in crop yield.
Yeah. So so the project where we just pulled that 50% off was what is called a hoop house. So they have 11 hoop houses at this test farm where we're working. Well, it's a commercial operation in Mendocino County, but so several of the hoop houses were held without CO2 for the we're on the fourth.
Controlled.
Oh yeah, exactly. Control. We were, because the farmers all want to know too. Plus, we needed that to exactly, so the rest of the community can also benefit from it. Good point. So, the sidewalls were all opened up. The end caps were all opened up. So really, this last growth cycle that they did only had a shade cloth across the top of the plants. The breeze, everything just blows right through there. And that's what the sensors do for us. So they pick up the daily temperatures, the wind, the light, radiation, and all that feeds into an algorithm. And it says, okay, at any point in time, put a prescriptive level of CO2 out there, and the plants just thrive on it. In fact, I was at the farm last year when the solar eclipse happened, and it was like, oh, there goes the system. It shut off and then turned right back on again during the solar eclipse. Yeah, it's pretty funny.
That's good. That's dynamic. That's good work. So, okay, wait. Teach us about this. This part seems interesting to me. So you have sensors detecting all of the variables, and that is, of course, very important to measure the dynamic state of the grow. And then there is a prescripted dose of CO2. So the algorithms say, okay, now it's the right time. Maybe my question is then, how do you know it's the right time? How often is the right time?
Yeah, it's
and how much?
Well, exactly. So some of this you're getting into the secret sauce of the company, but we've got some sophisticated instrumentation that we've been using to measure, how these plants respond. We don't have all the answers yet today, too. I mean, not only from species to species is it going to vary, but also even we think within cannabis, there's a lot of different varietals. So we think there'll even be variations within the varietals in how they produce with the CO2 and how they react with the other variables like light and temperature. So we don't have all the answers, but we're getting a handle on some of that stuff now. So it's really an exciting opportunity for the company. We,
maybe this is a good way to say it then. Is it true then that it's much different for tomatoes and peppers than it is for cannabis, or is it somewhat similar?
There's actually the tomatoes physiologically are fairly similar to a cannabis plant. So that one you might actually see some similarities. Other crops like the almonds or these things that are really desert plants, you're going to see some different heat thresholds with those plants. But one thing we do know is that the CO2 really bumps up the heat tolerance of the plants as well.
Bumps it up.
Oh, yeah. So, and this is where we think we're picking up big yield increases, right?
That would mean that areas that have typically more arid climates can then have a bit of CO2 dosed onto them, and then they can withstand the arid climate and grow through.
Oh yeah, and with the warming that's going on out in the Central Valley, I mean, it's really well documented out in San Joaquin that the temperature right now, they're getting I think they're predicting 60 days excess heat days a year now. So we really think eventually we can help those guys out there, not only with their organic production, but also with their water situation. So right, exactly. And the cannabis guys, they tend to be more in the mountains, you know, the less areas with less air pollution. So you know, there's a different set of environmental factors everywhere you go. Kind of like with the wine industry, they have the appellations, they're doing the same thing. So there's all these little microclimates, and that affects our technology and how it performs.
I was, again, thinking about how cool it is that you have banded together like scientists with environmentalists, with agriculturists, farmers, that banding together these groups, and now with cannabis as well, with the medicine. That is so cool. I like that a lot. And I think that's what really resonates with you were saying earlier, this mission-driven position that you hold. All right, so it's so interesting to me. What other cool patterns have you found, like increasing CO2 will make it withstand greater heat? Have you found other cool patterns like that?
I guess if I had one last thing for the cannabis guys in particular, and it was a concern for us, is of course, how does it affect the quality of the product? Because for the quality of that bud, the terpenes and the THC content, and you know, the chemistry is really important to these guys. And so at these farms, what we've been doing is we've been harvesting out of the control, harvesting out of the same part of the plant in the carbogation service hoops, and running everything into Sonoma Lab Works. And so we've been spending quite a bit of money to monitor the quality of the product coming out. And we're finding that we're either, you know, slight upticks, but generally on parity. So we're really pleased with that, because there's no deterioration in the quality of the product. That was a really big deal. What we have seen, and we're going to spend some of our R&D dollars, is we're finding that we're seeing some less mold. And of course, mold and mites and some of these issues that the farmers have, particularly with cannabis and other crops, we think that we can start to address some of those issues organically, without spraying chemicals, and that could be a really big deal for the industry. So
how would you solve with the mold?
You know, we don't have all the answers yet. We've got more questions than answers. Yeah, good. But you know, the growers are coming to us and they're going, hey, you know, can you help with this? And we're like, hey, one thing at a time, you guys, right? Right? Because we've got to build the company. So, but we've been lucky. We've been able to attract really great people, which makes it fun. You know, our core values are have fun, be agile, be innovative. We're very employee-centric. You know, it's about the people, and we're safety-centric. So we've got some really good core values. And
are we doing longitudinal tests? Those are good core values. Are we doing longitudinal tests on consuming the increased peppers and tomatoes and cannabis that have increase in CO2?
Not exactly sure what you're asking there.
If I'm consuming tomatoes that have had egg gas, if I'm consuming those tomatoes like once a week or once every couple days, and I'm doing that for a year, it's so hard to isolate variables and try and figure it out. But there shouldn't be any health issues. Are you concerned about?
Yeah, no, so we've seen a lot more healthier, more vigorous plants. So just the overall health of the plants is enormously better. So, you know, we think that they're more disease resistant, more pest resistant. So we like that aspect of it. But there is like one study out, I think was maybe run in Japan, that found there was some slight downtick in the zinc content. And there's a couple of studies out there, independent studies from our company, that said there's slightly less zinc in the grain or crop. We ran everything through the universities and found we were spot on. You know, we tested bricks, sugar content of the plants, and shelf life of the fruit. I mean, we ran, so we had the same questions, right? I mean, right. So
you did the rate testing.
Yeah, no, and and same with the cannabis. It's like, no, we got to check the full spectrum, microbials, everything on this to see where it's at. And so far, we've been in great shape on that. But there is some other things that the one I've noted, and we're going to continue to look at that when we go back to the food crops. Is what's going on with the zinc content? Don't have an answer for that. I've got a question right now about that. So yeah.
I'm happy that you're asking so many questions. We love asking powerful questions on the show, and that's really important that you carry that mentality of having tons of questions and wanting to do the raw science, get the good data, get as much data as you can collect on it. All right, so that's been pretty good. So now it's 2018. You're moving quickly, moving forward with egg. Now, what percentage of your time is going to be dedicated towards cannabis versus the tomatoes and peppers? What percentage of your resources were you looking at?
Yeah, right now for 2018, 2019, I mean, we're 100% focused on cannabis. It looks like the sales of the company are going to ramp up pretty quickly in the next 6 months. Yeah. And so we're going to have some operational challenges from a business standpoint to deliver on systems and to make sure, with our customers, we want to, under promise and over deliver. And so we want to make sure that we're building the organization and doing all the right things from a business standpoint and from a financing standpoint. We've got a really great board of directors. We've got a good science advisory board, and we've got a really good management team. So those kind of issues we should be able to work through pretty well. We use what's called the Entrepreneur's Operating System, which is a really cool platform where we all get our weekly stones and our monthly rocks. And, so we're doing some fun stuff that really keeps us on focus and on task to develop the business. And then, we're going to make some logical steps as they're presenting themselves to us about how we're going to expand the markets. So we got to kind of rate those and figure out how we're going to manage that, because every time you try to take a step like that, it consumes resources. So, a lot of companies have faltered because they either overextend or they don't have the amount of capital to finance that. So there's going to be some operational issues that we're going to have to be very careful, to build a good business. Yeah.
And then how do you change the tech stack? How do you improve the technology stack? Because right now you are spraying gently from the side of the crop or from the top, and then how is that being changed over time, and how's the software updating over time, etc.?
Well, the good news for us is we're going to be gathering a lot of data, and we see value in that data coming out of these growth sites. So the data is going to be valuable to us. So we're going to continue to mine that data and try to improve the systems. We already have filed, our first U.S. patent just got issued. We have a whole patent portfolio. I mean, I'm already looking at Gen 3, Gen 4, and Gen 5. We see that this thing is really going to migrate and improve, and that there's some other things that can happen with the systems and the technology. So we're on that. We're filing patents. We're just going to file our first, PCT, which is an international patent, next week.
And what's the tech look like again? Here's the crop.
Yeah.
How does it look like?
Yeah, so it's a little bit crop dependent. Trees obviously need the CO2 way up here. Yeah. Ground crops need the CO2 down here. So cannabis is an interesting challenge because it grows really fast and it gets pretty tall. So our system is designed to release the CO2 right where the light is incident to the plant, because it's the light and the gas that are interacting with each other. Right? They're uptaking the carbon, and the sunlight through photosynthesis converts it into carbohydrates and sugars. So it's really important that we get that gas right to the area of the plant where all this photosynthetic activity is going on. Yeah. So our system is like on a little ratchet glider system. Mm-hmm. We've got these clickers, and so it ratchets up.
The motor?
No, they're manual, but yeah. So when their crew of 10 guys comes in to install mesh trellis, for instance, it goes click, 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 goes right up, gets out of their way. They can install a mesh trellis or harvest the crop, and then it just glides right back down onto the baby plants that they just replanted. So it's really key that we don't interrupt the agronomic function of these farmers, because these guys, they work really hard, right? And it's like, no, these guys work hard. It has to be, it's what I call kind of elegantly simple and yet dependable. So, and then the sensors do the rest of the work. So it's all automated. You know, eventually there's probably even some room for some AI in this situation, but we haven't gotten that advanced in it.
So are the sensors then also seeing how high the plant is growing so that the system knows how high to go up and spray the CO2 where the photosynthesis is happening?
We have sensors in the array that can monitor that. So we're clearly looking at that capability. Yeah. Yep.
There's so much about the tech stack that I'm finding really interesting. And we have a couple other friends that are doing robotics in agriculture and also working on yields in agriculture. So this is really fun. And I'm excited to see where this goes in the future. What are you most looking forward to regarding the future of cannabis and the future of agriculture?
Well, I think water's going to continue to be a huge challenge globally for cannabis growers. It already is, to get their permits. I mean, the water is a huge issue for the cannabis guys, and I think it's going to really intensify in other areas. So I see that water issue is an ongoing problem. And, you know, and just with global population, there's going to be continuing pressure on the food supplies, and particularly, you know, look at like San Joaquin Valley and our, you know, the salad bowl. These areas are really getting subject to higher temperatures, so it's throwing some of the seasonal growing regimes kind of out of balance, and so I think we can possibly help, you know, level some of that out for these guys. And then the whole idea, you know, to fit in with California. With the renewable energy mandate, which, you know, you have biofuels that produce a lot of CO2, of closing that carbon cycle and creating a market for the carbon, you know, that really is something is the long-term vision of the company. And we think we see a path right now. So cannabis is the first step, and then we move into these other areas, and then the broader vision of the company, you know, we can get to these 30,000-foot kind of conversations about, wow, you know, we actually did something for the next generation. Yeah.
Yeah. I'm also so interested in how to tweak the variables of sunlight, soil composition, CO2. There's so many of these variables to tweak to see how to maximize crop yield. Like, in the evolutionary perspective we were just talking about, so what was happening millions or hundreds of millions of years ago with crop yields? What was optimizing the efficiency? What have we lost in terms of information since then? So I'm really happy that we put it into that perspective as well. Stu, this has been so much fun.
All right.
What a pleasure.
All right. Thanks a lot for having me on the show. Awesome.
Hey, it's been super fun. Egg gas. We have the link in the bio. Go check it out. Also, go and build the future. Go create. Go manifest your destiny. Thank you for tuning in. Much love. See ya.